Okay, this is problem 5.21. I've got the free body diagram written up there or drawn up there. Just a couple of items or a couple of pieces of information for you. I'm indicating a right angle in this upper right-hand corner. It's not, I don't know if it's imperative on your free body diagram, but I have it on mine. I'm also indicating that there is a right angle between G and segment AE. All right, so G is a roller, so roller has a perpendicular to the plane. So it'd be a 90-degree angle between the reaction at G and segment AE. A couple facts for us. Because of the angles, Gx is equal to 0.6 G. Gy is going to be equal to 0.8 times G. Setting up our equilibrium equations. The equilibrium of forces in the x direction equal to Gx minus Ex. That'll be equal to 0. Summation of the force in the y direction, -10 kips plus Gy plus Ey plus -5 kips. Because -5, of course, comes from By. -10 comes from point A or from W. This reduce, which would be equal to 0. I'm sorry about that. -10 kips plus -5 kips is -15 kips. I'm going to add that to both sides of the equation just to make it look a little bit not as goobly gobbly. So Gy plus Ey is equal to 15 kips. Now, that gives us two equations with two unknowns, or two equations with four unknowns. So we're going to reach into our bag of tricks. I remember that there are three equilibrium equations. I'm going to take the summation of the moments about point E. About point E. By doing that, that will help me eliminate a couple of the unknowns. Hopefully, anyway. So as a reminder, moments in the counterclockwise direction will be considered positive, and in the clockwise position will be considered negative. All right. Go collect our things here. So I see 10 kips is a player. It is 8 feet away. 8 perpendicular feet away anyway. 5 kips is 4 perpendicular distance of 4 feet. Gx is a player. Gx is a perpendicular distance of 3 feet. Gy is a player, perpendicular distance of 4 feet. And all comes out to be equal to 0. Clearly looking at our free body diagram, if the moment is about E, the 10 kip force causes a counterclockwise force that's positive. The 5 kip force is also positive. If Gx pointing going to the right would create a clockwise, so that's a negative force. And finally, Gy would also provide a negative moment. Doing the arithmetic, 80 kip feet plus 20 kip feet Oops. There we go. Plus negative 3gx plus negative 4gy equal to 0. Continuing on, that's 100 kip foot plus negative 3gx plus negative 4gy equal to 0. Doesn't really appear to help us until we recall that gx is equal to 0.6g and gy is 0.8g. I'm going to go ahead and substitute those values in. So this becomes negative 3 times 0.6 gx. I'm sorry, that's not true. There we go. 0.6g plus negative 4 times 0.8g. Negative 3 times 0.6 is negative 1.8. Negative 4 times 0.8 is negative 3.2. Negative 3.2 plus negative 1.8 is negative 5. So 0 is equal to, 100 kip feet plus negative 5g equal to 0. Add 5g to both sides. 100 kip feet equal to 5g. G is equal to 20 kips. If G is equal to 20 kips, if that's true, then Gx is 0.6 times 20, which is 12 kips. Dy is 0.8 times 20 kips. I think that's 16 kips. If that's true, 12 kips minus Ex would give us that Ex is equal to 12 kips. And we would eventually also be able then to solve (16 kips plus Ey equal to 15 kips. Therefore, Ey is equal to negative 1 kip, thus indicating that we have, or that I chose Ey in the wrong direction. My Ey would need to be, would actually in real life be down. So as my final solution, I would present that as Gx is equal to 12 kips, pushing toward the right. Ey is equal to 16 kips in the up direction. Ex is equal to 12 kips, pushing to the left. And finally, Ey would actually be 1 kip, pushing down. That's my final solution.